Hello and welcome to the mini test solving of the lecture 23 mini test. So here was the mini test for any of you who didn't see the video and are here to solve it. For those of you who came to see if they solved it correctly, let's get ahead and see. For the first one, we have to find the derivative of the function 2x squared. So for that, we will just use the formula because that's the only way we know how to do it for now. So we get the formula. We insert the function, because we remember the transformations of the functions, we insert x plus h instead of x, and this becomes this, then minus 2x squared as minus f of x divided by h. We open this up, so we basically square this sum, then multiply it by 2, we get this. Then we can cancel out the same terms in the numerator. And then we cancel out the h's from the rest of the terms, and the denominator, of course. And after that, we're left with 4x plus 2h, and since h approaches 0, we can cancel the entire second term out, and we're left with 4x as the derivative of this function. Now, for the second task, we had to know if the derivative can ever be negative for the given function. So for function x cubed, to find the derivative, we use the formula from before, and while it is slightly harder because it would be a cube of a sum, I believe that you can solve it by just breaking the cube of sum down, cancelling all that fits, and then you'll be left with the second term, so that so the one with h times x squared times some number, and that one in this example equals to 3x squared times h. So after h gets cancelled out, we're only left with 3x squared. Here I wrote out the cube of a sum. Just replace a with x and b with h. And since this first term is equal in the second part of the formula, like here, minus f of x, that first part will stay the same. So x to the power of 3. That one is cancelled out. All of these are left with b. And since all of them have it, we can cancel out the b or the h in the denominator. So we're left with h to the power of 2, h to the power of 1 times x times 3, and 3 times x to the power of 2. And that's how that all cancels out. So a short rule of hand would be that you basically insert x plus h and then solve it, and then if it's just like exponent, you take the second term, because the first one cancels out from subtraction, and the rest of them have h in it. This one has h to the power of 1, so this is the solution, meaning like this. You can write it all down, solve it by hand, but this is just a quicker way to solving it. So, to answer the question of the task, can the derivative ever be negative for the function x cubed? Well, the derivative formula is 3x squared, and we have to find if that can ever be negative. And for real numbers, it cannot. So no is our solution. Therefore, so no, the derivative of this function can never be negative, as the function will also never decrease, it only increases. Now, for the last one, this one is just the way. I think it's far too easy for you guys, but I had to give you one more, so make you feel confident about solving it. So, is the function increasing or decreasing if we have the y value for f of a, so we insert some a in the function and we get minus 5. If we take a derivative of the function and insert the same value into the derivative, we get 4. So what does this tell us about the function? We know that it's in the negative at the current a value, and the derivative, aka the slope, is positive, meaning that the value is increasing and it's under the x-axis. But it's only important if it's increasing, not where it is. So the answer is increasing. This was all. Thank you so much for tuning in to today's mini test solving, although a very short one along with the very short lecture. I hope everything went well. Thank you so much, and I'll see you all next time. Bye!